Hello and welcome back. In this video, we will understand a very important concept in computer science and engineering. And this concept, knowingly or unknowingly, is used in many basic courses of computer science and engineering, which are like digital logic design, computer organization, computer networks. So in all these concepts, we are going to solve many problems by using this concept. So this concept is very important to understand. So we request you to watch this video as many times as possible until you get the clarity. So let's start this concept. And what is this concept that we are going to learn? It is the power of bits. How many values can they represent? So that we will try to understand. So first what we will do is, we will try to understand this concept by using the decimal number system. So with the decimal number system which we are used to, we can easily understand the logic, and we will apply the same logic to the binary number system so that we can understand the concept very easily. So what is the concept? So here we are having a one digit space. So this is the space, and in this one digit space, how many different unique decimal numbers are possible? So that is the question. So what is that we are going to answer here is, with one digit space, how many different unique decimal numbers are possible, and what are the range of numbers, and what are the values that we can represent. So with one digit space, how many different decimal numbers are there? So there are 10 different decimal numbers are there. With one digit space, we can accommodate 10 unique decimal numbers, and the range is from 0 to 1. Try to understand this. So how did we get this? So the mathematical understanding behind this concept is, how many different symbols are there? There are 10 different symbols. And how many spaces are there? So there is only one space, 10 power 1. So what are the different decimal numbers that are possible? Which is 10. And the range of those numbers is from 0 to 9. So 0 to 9, there are 10 different symbols, right? So in this space, we can accommodate any digit between 0 to 9. Okay. What if we are having 2-digit decimal space? If we are having 2-digit decimal space, what are the range of numbers that are possible, and how many numbers are possible? Means in this space, we can put any digit ranging from 0 to 9, and in this space also we can accommodate any number ranging from 0 to 9 with different other combinations of decimal numbers ranging from 0 to 9. How many numbers are possible? So the different numbers that are possible is 100. And what is the range of those numbers? It is from 00 to 99. So what is the mathematical logic behind this? How many different symbols are possible? So decimal number symbols, it is 10 symbols are there. How many spaces are there? So with 2 spaces, it is 10 power 2. So the range, the different numbers that are possible is 100. So try to understand this logic. Okay. Now we will move on to our binary number system. So in the binary number system, we call each digit as a bit. Okay. So now with one bit, what are the numbers that are possible, and how many numbers are possible? So with one bit, only 2 numbers are possible. So how did I got that? It is, we are having only 2 different symbols in binary number system. In the binary number system, there are only 2 symbols. It is 0 and 1. Means with 1 bit space, we can either accommodate a 0 here or a 1. So how many possibilities? Only 2 possibilities. And what are the range of numbers? It is 0 to 1. The range of numbers in decimal system, it is from 0 to 1. Okay. So how many numbers? 2 numbers. So it can be either 0 or it can be 1. How did we got this? So there are 2 symbols and the number of spaces. The number of spaces is only 1 space. So which is going to be 2. Okay. So try to digest this logic behind, and this logic is applicable for any number system. Okay, so for example, if you have 2 bits, with 2 bits, what are the different binary numbers that are possible? How many different binary numbers are possible? And what is the range of those binary numbers? If we convert it into decimal, what is the range of those decimal numbers? So binary numbers, that we will try to understand. So with 2 bits, we will get a possibility of 4 different numbers, 4 different binary numbers. So what are they? So how did we got that? So it is 2 binary symbols, and the number of spaces are 2, which is 2 power 2, which is going to be 4. Okay. Now what are those numbers? So what are the possibilities? 4 different numbers. It is 0, 0, and this one is 0, 1, and the other possibility is 1, 0, and the other possibility is 1, 1. Now, if you convert these decimal codes into, binary codes into decimal, so what are the decimal number range that is possible? So here if you take this, it is 0 into 2 power 0 plus 0 into 2 power 1. So this is equivalent to, so the decimal equivalent of this 0, 0 is 1. So this, the decimal equivalent is, this is 0, is 0. And what about this code? So it is 1 into 2 power 0, and this is 0 into 2 power 1. So if you add this, the decimal equivalent of this binary number sequences, it is 1. And similarly, if you take this 1 into 2 power 1 plus 0 into 2 power 0. So this one is going to be 0, 2 power 1, it is 2. So the decimal equivalent of this binary number is 2. And what about this? It is 2 plus 1. This one is going to be 3. So what are the range of decimal numbers that are possible with 2 bits? The range of decimal numbers that are possible with 2 bits is from 0 to 3. Try to understand this. The number of binary numbers that are possible with 2 bit space, it is 4. How did we got that? It is 2 power 2. Try to get this point. So we are thinking about 2 different points in this binary, in this kind of understanding. One is how many bits are possible, and what are the range of decimal numbers that are possible from this range of numbers, from these 2 bit space or 3 bit space. So let's come to our 3 bit space. So what are the different possibilities? It is 2 power 3, 2 symbols, and number of empty spaces are 3. And what are the range of numbers? It is from 0 to 7. So it starts from 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and it is 1, 1, 1. So it starts from 0, 0, 0. You take any amount of space, it always starts from 0, 0, 0, and it always ends with 1, 1, 1. Similarly, if you take this 3 bit space, it always starts from 0, 0, 0, and it always ends with 1, 1, 1. So this one is going to be 7, and this one is 0. So let's convert some of these numbers and we'll try to understand this. So this one, if you take this, it is 1 into 2 power 0, 0 into 2 power 1, this one is going to be 0, 0 into 2 power 2, whatever we multiply with 0, it is going to be 0. 1 into 2 power 1, which is going to be 1. So the decimal equivalent of this 0, 0, 1 is 1. And for example, if you take this, as we have already seen, it is 3. 1 into 2 power 0, which is 1. 1 into 2 power 1, which is 2. And 0 into 2 power 0, 2 power 3, 2 power 2, which is going to be 0. Okay, let's make it simple. So 1 into 2 power 0 plus 1 into 2 power 1 plus 0 into 2 power 2. So this one is 1, and this one is 2, and this one is 0. So 2 plus 1, the decimal equivalent of this 0, 1, 1 is 3. And similarly, if you take this, So the decimal equivalent of this is 5. So which is 1 into 2 power 0 plus this one is 0, sorry, this one 0 into 2 power 1 plus and 1 into 2 power 2. So this one is 1 into 2 power 2, which is 4, and this one is 0 and this one is 1. So 4 plus 1, the decimal equivalent of 101 is 5. Okay. So the range of numbers that we are going to get, the range of decimal numbers that we are going to get is from 0 to 7 with 3-bit space. So you are going to get different kinds of bits with the number of empty spaces given. So the very important point to understand is, and how many numbers we are going to get. So these are the different kinds of bits which are going to be there in the process of solving complex bits. Okay, and that is why we said that this concept is very important to understand. So there is another shortcut method. So by using this shortcut method, we can easily write these binary numbers. So what is that shortcut method is? So if you want to, so the kind of how these bits are to be placed in this rightmost space. As we go on, how the bits are to be arranged, that we will try to understand. As we are in the 2 power 0th position, which is 2 power 1, 2 power 0, which is going to be 1. So what is that that we need to understand? The shortcut method is, if it is the rightmost space, make it as 0, 1. So 1 space means 0, 1. Make it 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. This one is 0, 1 and this one is 0, 1. So there are 4-bit spaces. So the number of numbers that we are going to get, binary numbers we are going to get is 2 power 4, which is equal to 16. So these are all 16 possibilities. Okay. Now this second space, which is 2 power 1 and which is going to be 2. So as we are getting 2, what we have to do is you take 2 zeros and 2 ones and fill those spaces. It is 2 zeros and 2 ones. It is 2 zeros and 2 ones. And this one is 2 zeros and 2 ones. Hope you are understanding this concept. In this space, in this, what is the position? It is 2 power 1 position, 2 power 2 position, which is equal to 4. Means 4 zeros and 4 ones. And again 4 zeros and 4 ones. And what about this? I think you got that point. So the position is 2 power 3. This position is third position. 0, 1, 2, 3. So 2 power 3, which is going to be 8, means 8 zeros and 8 ones. Total 16 possibilities, right? So 8 zeros, 1, 2, 3, 4, 5, 6, 7 and 8, and 8 ones. Okay, so if you take this, what are the range of numbers? The range of numbers is, it is going to start from 0. 0, 0, 0 is always going to be a 0. And if you take 1, 1, 1, so this one is going to be 15. And this one is going to be 14. So what you have to do is, you take randomly 5 different codes, 5 different these binary numbers, and try to convert those binary numbers into decimal. And so you convert all these numbers into decimal. So it would be a practice for you. So what you have to do is, after completion, after listening to this video, after understanding this concept, you convert all these binary numbers. You write all these numbers first and you convert all these numbers into decimal. So this is going to be 0, 1, 2, 3. In the same way, we are going to get all the decimal numbers ranging from 0 to 15. Okay. So this is what the power of bits. How many values they are going to represent. Thanks for watching the complete video. You have come to this point, means we are hoping that you are enjoying our content. You are enjoying our content and haven't subscribed yet, please subscribe to our channel. We will post at least one video every day. Please subscribe to our channel and press bell icon for the latest updates. And after watching every video, please like our content. Your likes will help us a lot in growing. And share the content to all your friends and family members. That will help us to grow and help you to grow. Thanks for watching.